As we speak, 2 different space probes from 2 different countries have been collecting samples from the surface of 2 different near-Earth asteroids. One of them is on its way back. And at the same time, in China, people are preparing the launch of a lunar probe, lunar lander, that will collect and bring back to Earth lunar samples for the first time since 1976. And everywhere in the world, agencies, laboratories, and private ventures are developing ways of extracting water or other interesting molecules from the regolith of the moon. So I don't think that it is time for space resources mining, but it is already time for interaction with space resources. And to discuss how we'll go from here to the exploitation, I have 2 gentlemen with me today. On my left is Jean-Jacques Dordain, who is the former Director General of ESA, the European Space Agency, but today is here as a member of the advising committee for the Luxembourgian government. On my right is Mr. Bruno Paglicia. Okay, I got it. Paglicia from the company SAISB, who is preparing what we'll let you present this. Okay. And on the screen is Mr. Marc Serres, who is director of the Luxembourg Space Agency. And we may have a 4th panelist popping up when the connection is ready. So first of all, it's quite impressive that the Luxembourg is really present a lot on this panel. I'd like each of you to tell us how did you come to get an interest in the exploitation of space natural resources?
Yes, thank you. Very simple. I think that I am interested by space resources since Luxembourg has decided to take an initiative on space resources. So if I am here today, it's thanks to the government of Luxembourg, who was the first one in Europe to take an initiative on space resources, and Marc will speak much better than me about that. But just to say that Luxembourg was #1 in Europe and #2 in the world, just after United States, because all these activities in Europe have started February 2016 with a press conference given by the Vice Prime Minister at that time, Etienne Schneider, and myself. I was next to him to announce that Luxembourg was taking such an initiative. And I must say that at that time, yes, it could look science fiction, but I would say that 4 years later, it's not anymore science fiction by far. And that it's due to the convergence between that initiative on space resources and the lunar exploration. Because when we have started and when we were speaking of space resources, it was mostly resources from asteroids, because the asteroids represent a fantastic source of resources. But step by step, through the lunar exploration, there was a convergence between 2 initiatives, the first one on space resources and the second one on lunar exploration, because lunar exploration gives a market to the exploitation of space resources, because there is no lunar exploration without space resources. So it's not anymore science fiction, because it's a necessity, since the Artemis program wants to not only to land on the moon, but to stay on the moon. You cannot stay on the moon without using space resources. So this is that convergence was created that momentum, which has created an acceleration of activities on space resources.
Thank you, Mr. Serres. Could you extrapolate what is your space agency's position on this activity?
Yeah, absolutely. And in fact, Jean-Jacques just said that we announced this initiative in 2016, but the whole thing started a bit earlier during discussions between the teams here in Luxembourg and NASA. And at that time, our minister was intrigued by this subject. And we started working on that, participating to conferences, meeting people from research, from industry, various stakeholders already existing in the domain of space resources, which is not a new thematic. I think this is something that was already planned in the Apollo missions during that period, but has never been really developed at the pace that we observe today. And after this 1.5 years investigations, I think we came to the conclusion that that was an extremely important topic for the future in space, that it was also an opportunity for Luxembourg to be part of this development with as well on the longer term economic returns for the country and a benefit for the whole society in Luxembourg. And so we started this initiative, as Jean-Jacques Dordain mentioned. I think what we did immediately when to start this initiative, it was to understand the different challenges we were confronted with. And during this period, even before we announced this start of the initiative, we have done an analysis of the legal framework situation. And I'm sure I will be able to expand a little bit more on this aspect later in the debate. But that was the first step that we took within a strategy that we have elaborated. And I think this is also has been done with the support of this advisory committee that we have set up, of which Jean-Jacques was one of the first members, and where we really are tackling the different challenges that we see here on the question of space resources.
Thank you. Before going any further, I want just to make sure that we understand what you're talking about. This is about exploiting natural resources in space and use them there.
Absolutely. I think that, and this is the reason why, again, the utilization of space resources is an enabler to stay on the moon. And after that, to go beyond and to go to Mars or even further. But so this is to use these resources for the missions in space. So this is not to bring back any resource to planet Earth.
Yes, I wanted this to be made clear because we've read many articles on the probe that will go to the metallic asteroid Psyche, and people fantasizing about the quantity of gold that could be there.
Stephanie, if I may add to that, we have done a study on the value chain related to the use of space resources. And of course, during this study, we have looked at the topic from different perspectives, but we have also tried to identify use cases. And I think very interestingly, the use case going for resources and bring them back to the Earth is something that did not really come out as something that is viable, at least in the current situation, and would certainly not be the first use case or be part of the group of use cases that would bring the most benefits in general. And just to in certain way confirm what Jean-Jacques just said before, the use case that has been identified as being the one that will probably be the first one that would realize is using water, a resource that you can find on the moon, as a propellant. And I think this is showing here that the first benefit of the space resources will be in space.
Well, so that brings us to you, Mr. Paglicia.
Yes,
I will
correct.
get it before the end of the
Okay,
So you're coming from the oil industry,
that's correct.
and so you founded SAISB, and you're the industry on this panel. Is the industry there? That means that it's getting serious.
Yes, definitely it is. So I am a geophysicist, and I was working for a big French energy oil and gas company for the last 20 years. And I was deeply involved in the exploration of Earth resources. And I have found that there are a lot of synergies between what we are doing on the Earth and what people want to do on the moon, because on the Earth, we are looking at very hard to access resources because we are supposed to drill several kilometers in the crust to get access to the oil and gas. And for space, you have to go in a very hard to reach places like the moon. And so we have the same problematic. We need to go there. We need a big company with a lot of capital to go there to invest. And the first step to go there and to invest so much money is to identify and quantify the available resources. And this is where I have started a new company in Luxembourg, which is called SAISB, for developing a geophysical imaging tool for beyond Earth exploration. And the first playground, I would say, is naturally the moon. So I'm starting a new venture, a new business, a new adventure, I would say. I'm very excited to do so, and we'll see in the future if it works.
And what does SAISB mean?
So SAISB means seismic for beyond Earth exploration. So seismic is a proven geophysical tool for the Earth exploration of the resources. So the idea is to bring these technologies, which are already working on the Earth, who have proved that it works very well, to characterize these resources, to know exactly what we are talking about and what is the quantity of it. Because if you put a number, you put some money on the resources, and this is how to start the business. So this is the first step of the exploration chain, the identification and quantification of the resources, to see if there is a business. Because without that information, it's just a concept, basically.
You want to say something?
Yes, just to take what Bruno was saying, that and this is a discussion that we had many times in the advisory committee of the Luxembourg government, is that the space resources is first a question of resources, much before to be a question of space. And this is the reason why the resource industry on planet Earth, they have developed a lot of technologies, a lot of process, and this is the reason why I am so glad that some of the resource industry are starting to be interested by the identification, extraction, and transformation of a resource in space. Okay, Marc will speak of the inauguration of the new European Space Resource and Innovation Center in Luxembourg. But just I have picked up one sentence from that inauguration, is that the space resources are much too big just to be addressed by space actors. And this is the reason why the resource actors are important, because they are much older than the space industry. And they have a lot of technologies, again, which will be very useful for extracting and using space resources in situ.
Well, so I've made my shopping list. And to exploit space resources, I think we need detection and identification of resources, technologies to access them, to process them, but also a market to buy them, and not to forget, a legal framework to make sure it can be done. Is there a logical order in which all this can be done, should be done, and are we there yet?
Oh, we have made progress there because, as you have said, there are several aspects which are technical, technological, financial, legal, and commercial. And as I said, the very first market for space resources are the missions of lunar exploration. There are a lot of projects on that, which is on the US side called the Artemis program, with a plan, the landing of the first crew in 2024, and a sustainable lunar base in 2028. And even if there are some delays, this is during the decade. And that is something which is interesting, because it means that there is a market which is not too far away. And in front of that, NASA, which is for the time being the most significant investor in that lunar exploration program, they have developed, again, methods, and they are ready to buy services from and resources from commercial companies. They are looking for partners, because contrary to the Apollo program, it's not anymore a race between countries. It's a cooperative program. And number three, they have developed a legal framework, as well as Luxembourg, but that Marc will speak of that. And just to say that when you read the Artemis Accord, which have been signed by 7 countries together with NASA, these Artemis Accords, they are speaking almost only of space resources. The 3 operative sections of the Artemis Accord are a section on space resources, a section on safety zones, and that there is some legal aspects there, and the 3rd section is on debris. So all the Artemis Accords, which are the basis of the lunar exploration, are related to the utilization of space resources.
Mr. Serres, as an agency, how do you manage all this?
Yeah. I think your shopping list is addressing exactly the 4 challenges we have identified in the work we have done in preparing this initiative, and that starts with the legal framework. I think Jean-Jacques just mentioned it. We have made a first step in Luxembourg in putting in place a law that is specific to the use of space resources. And I think this is an important political message as well, because there is one article that also created a lot of debates on international level, which says basically that we consider that the space resources can be appropriated. And that's for me a fundamental element to be able to really develop all the activities around. So you have to be able to take them and to do something with it. And even going beyond that, commercial or private actors should be able then to commercialize either the raw materials that can be extracted or all the products that can be derivated from these resources.
Very shortly, just to make a little aparté, it's how does this comply with the existing treaties?
But it's fully compliant. Well, that's how we see the things. Of course, you will certainly see in the literature that some people disagree with that. Which, of course, we are ready to discuss. That's clear. But from our perspective, and we have done this study, as I mentioned, even before we started the initiative in 2016, with experts in legal questions on space law, and the way our law is formulated, I think, is fully compliant with the international treaty. And in particular, the large majority of our law is just implementing, in a certain sense, the authorization and supervision of these activities related to the use of space resources. So from our perspective, we have done an important step now on national level, but it's absolutely not, I would say, the only thing that needs to be done. And we remain extremely active also on the international level. I think over the last 3 years, well, this year is a bit exceptional, but the years before, UN has put the topic of use of space resources on their agenda. That means that today we are already discussing all together around the world about the best way to make this possible. And of course, and that's normal, I believe we around the world, the awareness, the level of understanding, the competencies is very various. And I think we have also done a lot of work to explain to other nations, other agencies, what we have in mind here and what the opportunity is. And again, it's not only a point that is of interest for the small Luxembourg. I think this is a topic that will require really the involvement of a very broad variety of stakeholders, and I think Jean-Jacques made it very clearly. Only on the question of technology, we talk about the resource here, and involving also industrial players, maybe existing industrial players from terrestrial, let's say from the terrestrial domain. I think this shows already how broad, in fact, this topic needs to be considered. And so, again, from the legal perspective, certainly there is some work to remain to be done. And I'm also sure here that the elements that we find in the Artemis Accords now are sort of a new step in envisaging the use of space resources now specifically on the moon. And this will be, in fact, the first opportunity to really do real things, start having real activities of either prospection or extraction, and starting processing and maybe building first equipments or first structures with the resources that we can find. And so this is really here, let's say, going beyond what we have done in Luxembourg, but I think everything today is done in the spirit of the international treaties.
If I may add a word on that, from the industrial point of view, this is probably the most important step to start with, even if it's at the very end of your wish list, is to put this legal framework on the table, because without that, there is no business, basically. No industry will go there if there is no legal framework. So it's really a key step. And I'm glad that some countries like the US and Luxembourg started with that, because it's a key element.
Well, and what is the other steps you require from the... Well, you're based in Luxembourg. That's
correct.
That's not innocent.
No, not at all.
Yeah, and it's because the legal framework is there.
It's by far the most active countries in Europe on that topic. It's a country we have shown dedication to that aspect for many years now. And to start this business, it's a very risky business. We all know that it will not be easy to go there. It will be very difficult. A lot of challenges are facing us, and we need a strong political support and a long-term political support on that topic. We cannot afford as an industry to have a political decision which will be changed each time there is a new leader, I would say, in the countries. We are talking about something which will last for many, many years, if it's not decades. So we need a strong commitment from the countries, and we need long-term investment as well. So this is how I see Luxembourg from their initiative. It fulfills all these needs we need to start the business, but it's not the only needs we have, obviously, because to attract these big companies in the business, we need to show them that there is a business, okay? And for that, the only people who can help us as a small startup to start the activities is to have an enabler, people who will support us without expecting an immediate return on the investment. And this is where the space agencies has a very strong role to play to help us, is to allow us to size the opportunities to start to do business in space. And this is, I think, the most important things to start the business is to show the big energy company which may be interested by this business, is to start by doing a proof of concept of the two first list of your wish list, which is the identification of the resources and how to extract them. We have to show it's possible. And this is where the space agencies could help us a lot to give us the opportunity and possibly the fundings as well to demonstrate that. And once the demonstration is done, the big player will come.
Yes, because your company is planning to bring detectors, sensors there. So that means you need partners because you will not bring the vehicle yourself.
Yes, it's quite expensive. So Size B is really dedicated for the first item of your list, which is the identification and quantification of the resources, which is the very first break of the value chain we have to unlock to make this business a reality. And to go there, as for any activity in space, it's very, very challenging and expensive. And we cannot do that alone without someone backing up our activities. And this is not the big company who will do that, because the big companies are not yet convinced that there is a market. So this is where the public agencies, like the special agencies, could help us. And once the mechanism is started, after the big companies will come.
Well, back to you, Mr. Serres. I understand that your agency is well involved because I've seen you on board the ERA mission to the asteroid Didymos, where you will play quite a significant role. And also you've just opened the ESRIC, the European Space Resource Innovation Center.
Innovation Center, yeah.
So could you tell us more about that?
Well, maybe coming back to your shopping list, I can finish a little bit what we have done over these different topics. And I was saying that you are here tackling or touching the 4 big challenges that we identified. So we talk now about the legal aspects. I think the technological aspects remain still a challenge. Because yes, there are things that exist for Earth, but we still need somehow to have the necessary means to advance also in space in conditions that are sometimes slightly different. And also, I think I would add to this aspect, it's not only to have the technologies to be able to prospect, extract, process, and do everything what is in this value chain, but it's also the knowledge of the objects where we go. And there I would say a mission like HERA is of particular interest for us. I think there we have found a nice synergy with, let's say, the first objective that was to demonstrate the capability to deflect an asteroid if one day there would be one dangerous one that is coming and risks to collide with the Earth. In fact, to understand this process, you also have to have a very good understanding of the object itself. And here we are talking about an asteroid. Asteroids are identified as interesting sources or places where you can find resources. And so we have seen here an interesting synergy by the need to characterize the asteroids. So it's important for, let's say, the discipline of planetary protection in case of, an asteroid that would collide with the Earth, but it's also very important for the aspect from space resources. Here we will also embark a very small satellite that will contain a radar, and this radar will be able to characterize the structure and the composition of the asteroid, and will give a lot of very interesting information. If you talk with the scientists that study the asteroids, I think you suddenly discover that we know so little about these objects, and each time a mission goes to an asteroid, something new is discovered. I think this is also part of the challenge. Maybe we know the moon a bit better than the asteroids, but still, I think when you go deeper in what needs to be done, even on the moon, which is very close to us, that we even can see from the Earth, I think only the fact to move on the surface of the moon today is a challenge, because we don't have maps, we don't have a Galileo that is turning around the moon. So there are really a lot of challenges in front of us from a technical point of view. The third aspect is the financial aspect. I think we just heard Bruno talking about the need here of financing. I think it's clear for us that even the space agencies will not be able to go for that alone. We will need also the contribution of the private sector, and we have here made a lot of efforts also to convince others to join this initiative, and particularly the terrestrial mining industry and all, let's say, the players that are in this domain, because they can bring an important contribution to it, but also are those that potentially may invest in the future in these type of missions. And last but not least, I think this has been addressed as well, is the business aspect. I think we need here to have a market, and this is challenging, because here we have to somehow build up a complete value chain in parallel. If you can dig a hole somewhere on the moon, it has no sense if you cannot sell what you're extracting to someone. And this one, if he cannot process these raw material, maybe add some value to it and create, as I mentioned before, maybe oxygen for future life science activities, or create propellant to refuel the equipments that will be on the surface of the moon, or have to go back to Earth or somewhere else. I mean, we need here really to develop a complete value chain, and this is really a big challenge. I think we need here really the involvement of an extremely large variety of players. And this is why here in Luxembourg, we're also extremely active in trying to find people interested in this domain, because we will not be able to do everything out of Luxembourg. That's much too big for Luxembourg alone. And so we are really encouraging first Europe to be also a player here. I think it's an opportunity for Europe to be a leader on a future extremely important topic for space. And unfortunately, ESA has already taken some advance, and I think we have in Europe to wake up and start really be much more active on that. We still are trying to push this subject. I think at the level of the European Space Agency, we have found now a very good partner, and that gives also now a certain European dimension to the initiative we have started. But definitely for us today, it's important that this project is somehow upscaled, is internationalized, so that we really can make it happen.
Well, and recently, ESA has launched several studies for in situ resources utilization on the moon. But to me, it seems it's only scratching the surface just to test if it's possible. What is the next step we should prepare to, let's say, to go beyond the surface?
This is where I think using some tools used on the Earth for the business, for the oil and gas industry or the mining industry, is there to provide a full 3D image of the underground. This is
How far? How deep?
we can go whatever we want in terms of penetration, because on the Earth we can go down to several kilometers.
Mm-hmm.
I don't think we will go that deep on the moon, to be honest with you. We can go down to a few tens of meters, maybe 100 meters. The idea is to compute the volume of resources available to make sure that the business is flying itself. And this is where I think seismic imaging, because I realize I didn't explain what is seismic. So it's basically a way to image the underground of whatever the rocky bodies we are talking about, the Earth, the Moon, or asteroids, or Mars, or whatever, by sending sound waves and recording the sound waves reflected by the geological layers on the underground. It's like an X-ray, basically, like when you do X-ray to image the interior of your body. It's more or less the same way of functioning. So this is, to me, the first things we have to do to demonstrate that there is something interesting to go for in terms of quantity and quality as well. So it go deeper than just scratching the surface, as you say. But scratching the surface is the first step. We need to be sure that there is something already on the surface, and after we can go deeper. This is how I see the first, I would say, technical steps of this exploration of the moon resources.
And Stéphane, if you allow me, maybe I can say a word about these plans of ESA, and I take this opportunity maybe to say a word as well about the European Space Resource Innovation Center. So indeed, we have announced its launch now 2 days ago. This is a center that addresses a specific need on the research part. What we have discovered through the different workshops and contacts and networking that we have done is that there exists already a community that is interested in these aspects, but it's quite distributed, small groups at different places, and there was no central place where this topic was really at the focus of the research. And so we decided in Luxembourg to create a research group. And between us, the first idea was to do it within the Luxembourg Space Agency. That was the original idea. But of course, as always, discussing and trying to find, let's say, the most efficient way to do the things and not reinventing the wheel at the end, the discussions with ESA brought us into this idea of an European Space Resources Innovation Center that would, of course, have a national component. And there we are working with the Luxembourg Institute of Science and Technology, which is an existing research center in Luxembourg. And ESA is our European, I would say, first strategic partner. And I'm saying that because here the intention is not to have a purely national center. Here, I think it's important here that this is a platform to offer all the research groups in Europe the opportunity really to work together and create a critical mass on this topic in Europe. And so we have already very interesting discussions with other agencies or other countries that are interested to work together with this center, as well as in industry. I think it's important here not to forget, even though, of course, here we would focus in a certain sense on research, so on public research. I think at the end, what we are looking for is to create technologies that will serve for future economic activities, economic developments, where industry can take over technologies that have then been developed and come up to a certain level of maturity, and so that they can then use them for more operational and commercial activities. And this is why we have this innovation in the title, because we have that in mind. It's really here to to create or to complete the puzzle of different elements that the industry needs, going really from education, because you need the people able to do that, to research, financing, and of course, the whole innovation cycle inside the industry. So that's one important aspect as well of the center. ESA, being here our, let's say, strategic partner, decided to implement a number of their activities. And I think here, to come back on what you said, what ESA is focusing, at least at this point of their developments, is trying to extract oxygen from the regolith of the moon. And so this is the first technologies that they want to develop. ESA has developed or has set up, I think last year, a strategy on space resources, and we hopefully will be able to expand also the technological activities that will be performed within ESA over the next years, also with increasing interest of the member states of ESA, which has been already the case now over the last months.
Well, all this is really promising. Well, regarding the necessary market, I know that you've been proposing an interesting test to students on how these resources could be a game changer.
Yes, and this is something that I am doing again with Luxembourg, the agency and the Luxembourg University, is that we have asked students to redesign ESA missions which have been done and very successful. And we have selected 3 missions, Mars Express, Herschel, and Rosetta. And we are asking the students to tell us how they would redesign these missions under the assumption that they would have access to space resources. And this is to them to define the space resources which will change the way these missions could be redesigned. And I think that this is a very interesting exercise, which involve 3 teams of students of the Luxembourg University, and the work has just started. I could convince the 3 ESA project managers at that time, who are retired, like me, by the way. So they are the coach of these teams of students. And I am sure that this exercise will demonstrate, and concretely, it's not again a business case. It's much more concrete to see how space resources would change totally the way we can make future space missions compared to past space missions. And I am expecting a lot from this exercise, and it's good to have students there because they have no prejudice, no heritage, which is the worst. The limit is on imagination, and I am waiting for the results with great expectations.
Well, my imagination.
And Jean-Jacques, that's really a great idea that you have proposed there. And I must say, I'm very excited to see as well what the results will be.
Just to give an example, Herschel, for example, which is one of the all missions of ESA are fantastic, but Herschel has given a lot of results. But Herschel, we have stopped the operations of Herschel after 3 years of operations just because there was no more any cryogenic liquid to cool down the instruments. All the rest of the mission was working perfectly. So
just because
yes.
not everybody knows what Herschel was. Herschel was an infrared observatory with the largest mirror ever sent to space.
Absolutely. Yes, and the instruments were cooled down by cryogenic coolant, and this is the mission has stopped just because of the quantity of liquid available on board. If we have had access to a source of cryogenic liquid there, we could have continued that mission for much longer. And this is exactly what we would like to the students to demonstrate.
Okay, more than a mission, actually, it's a whole ecosystem that could be derived from these resources.
Absolutely. Let's say the space missions today are the only exploration missions which are made where you have to bring every kilogram of hardware, every liter of liquid from the start point for the entire mission, and that no other missions is done like that. You are always using in situ resources to make your mission much more sustainable. So space resources will make the space missions much more sustainable, starting by lunar missions. The astronaut of Apollo, they could stay only there for very few days, just because they had no access to any resource in situ, meaning that they had to go back quickly to planet Earth to have again resources to live. So this is the reason why for lunar exploration, space resources is just a necessity. There will not be any lunar base sustainable without using the space resources.
And also
making of the moon a fantastic laboratory of exploitation of space resources. And the day we have had that experience, we could go much beyond.
And they were also living only on fuel cells. That could be today with water from the moon could be refilled. I don't know.
Yes,
I'm not a specialist.
No, I must say that water, Marc was saying that water is the first product that which will be produced on the moon. And water is necessary for life support, is necessary for fuel, is necessary for energy. So when you can produce water on the moon, you have access to a lot of subsystems which make, again, your stay on the moon much longer and much more sustainable.
Well, I know that you're coming from the oil industry, but we've been talking about, let's say, simple molecules and fluids. But would your system be interesting also to detect other kind of resources like minerals?
What I would like to say is that even after decades, even after a century of exploration on the Earth, we are still amazed by what we are discovering. We have to be very humble. Each time we do a well, we are discovering new geological settings, new things that we are not expecting. So I think we will be very stunned by what we will discover on the moon. We have to be prepared to be really impressed by what we will discover. So I cannot say exactly what I could discover with these seismic imaging tools, but I'm sure we will see much more what I could expect. So water is the most obvious one. We can expect maybe the first usage of the space resources could be a fuel station on the moon, because basically put fuel in a rocket or putting fuel in a car, it's more or less the same activity. So this is something we know how to do it, and this is probably the first.
The water well, the oasis on the moon.
Yes, but this is the basic idea is to make a refueling station over there to allow the rockets to go much further than the moon or Mars. So this is probably the first use case. This is what has been already identified by these studies that the Luxembourg Space Agency has done in the recent years. And beyond that, minerals, rare gases, other resources, probably we have a very little view of what we could expect. This is what I think, basically, because this is what I see on the Earth. We are still very amazed, even after decades of exploration, about what we have found on the Earth.
Well, just I want to rebound on something you said earlier regarding protected areas on the moon in the Artemis Accord? What is this?
No, it's again. I have just read the Artemis Accord, and one of the section, which is an interesting section, just the section after space resources. The Artemis Accord defines what they call safety zones, and the safety zones is there just to avoid any interference between different activities on the moon, meaning that when you have an activity somewhere for extracting, for whatever, you draw a safety zone just to make sure that there will not be any damage from one zone to the other zone. And obviously that creates some discussions among the lawyers, which is more than okay, because they consider that safety zone can be taken as proprietary zone, which is not how myself I understand, but I am far from being a lawyer.
It's more like the sharing of the spectrum. It's a place you can use, and we make sure that you don't.
It's a place that you use with no detriment or consequence on your neighbor. This is the way myself I understand the safety zone. But again, I don't want to enter into that type of debate because I am far from being an expert. But this is just to say that these Artemis Accords are mostly focused on exploitation of space resources, because again, this is a key for sustaining lunar exploration. Without space resources, there is no sustainable lunar exploration.
Okay, and well, this might become a big geopolitical issue because, well, these accords are only signed by a few partners. More people will go to the moon.
They are signed for a few partners today, but as usual, they need some time to have other partners joining them. Again, I don't want to speak for Luxembourg, but what I have understood is that Luxembourg, as well as the other signatories of this accord, they are more than ready to discuss that in wider forum, and I am sure that, again, there will be progress to be made, but I think that the legal framework will evolve together with the reality, because usually the law is developed together with the reality, and lunar exploration will be a reality.
Well, we are coming to the end of this discussion. Does anyone want to conclude something?
I think that we can conclude today, but does not conclude the exploitation of space resources. I think that this is a matter which will make us all very busy in the next years.
Well, I must confess it's quite strange for me because we're discussing about oil industry, drilling resources, extraterrestrial resources, and deflecting asteroids. It looks like science fiction, and it's no more science fiction. It's very, very...
No, there is, and that I shall take again a sentence which has been mentioned during the inauguration of ESRIC, is that this is a dual-use activity, and dual meaning space and planet Earth at the same time. I think that we can export from planet Earth a lot of technologies which have been developed on ground to use terrestrial resources, and we can import from space a lot of things which will be made on the moon, including and maybe in particular the cooperation, because the lunar exploration is a cooperative venture. Cooperation among countries, cooperation among agencies, government and industry, and cooperation between the space industry and the resource industry. So it's a laboratory also of cooperation.
Well, gentlemen, thank you very much for all these really interesting insights. If there was an audience, I would ask for some applause, but unfortunately, the conditions are quite tricky. Thank you very much, and I'll see you next year on the
Yes,
same
see
panel
you,
to
see you
see
next
how
year.
it
Yes.
evolves.
Okay. Thank you.
very
Thanks a lot.
Thank you very much.
Bye-bye.